didn't stay at Holiday Inn Express last night. But I am John Olson. It's a pleasure to be here, and Doug sends his regrets. I'd like to start out with a little vignette, a little historical snapshot. On the 9th of November, 1967, Mobile Launch Platform 1 was used for the first time to launch the first Saturn V unmanned vehicle for Apollo 4 mission, and it was also launched from Launch Complex 39. That very same launch platform, depicted here, MLP-1, would go on to be used for Apollo 8, the first crewed flight to leave Earth orbit as it traveled around the moon. Also Apollo 11 mission, the first mission to land on the moon, as we're well aware of. It was also used for Skylab and Apollo Soyuz in our joint mission between the U.S. and the former Soviet Union. And upon reconfiguration, it was also used for the space shuttle program, from which STS-1, the first shuttle flight, was launched. And it went on to be used 51 times, became the workhorse of our entire fleet there. And then on the 15th of March of this year, 2009, MLP-1 was used to launch the last shuttle flight, STS-119, that returned safely just a little bit ago. And on March 25th of this year, 2009, it was officially turned over to the Constellation program to be used later this summer for the upcoming Ares 1X flight test from Pad 39. And this will be the first test, the first major test for the Constellation program. And this is the beginning of our new human transportation system for the next space stage. So essentially, the journey has begun. And of course, last year we celebrated our 50th anniversary at NASA, and this year marks the 40th anniversary since we landed on the moon with the Apollo program. And so over the past half a century, spaceflight has given us profound impacts not only on our nation, our planet, but all of humanity. And I think as we look at the benefits through innovation, inspiration, to a whole broad spectrum of generations, and also the many real and breathtaking benefits, it's truly going to be an exciting next space age. And as we look at those 50 years, we're entering into this new generation with a new portfolio of vehicles that will transport humans first to the International Space Station, then returning to the moon, onto Mars and beyond, and who knows. We're focusing clearly on safe mission execution, efficiency, sustainability, robust partnerships, not only with commercial industry and international partners, but other government agencies, academia. And we're also strongly focused on innovation, discovery, and inspiration. I mean, one might say that we're really going to be lean, green, and a mission-focused machine. So this year, with the most recent budget guidance, we are retiring the Space Shuttle in 2010. That's been confirmed, and we're also developing that next generation of vehicles. And compared to Apollo, we're going to put 3 times more mass to the surface, twice as many crew members for twice the duration or more. We're going to have global lunar access at any time return. This will ultimately lead to an outpost with a sustained human lunar presence, hopefully of an international variety. So we're, as Mike said, definitely in the next space age, and it has begun. So with that, I'd like to go back up, please, one slide. I apologize. 2009 marks an absolutely pivotal year for us, and it's not only a unique historical inflection point of opportunity, it also presents a lot of challenges, as you're probably well aware of. It started out with the new administration, and we had our Lunar Electric Rover vehicle as the final element in the President's inaugural parade. And right now we're strongly in the throes of budget execution and budget work. Actually, 3 of them. We've got the 2009 budget. NASA received $17.8 billion, and our top line from the February 26th President budget was $18.7 billion. In that, it endorsed not only a robust program of space exploration involving humans and robots, but also retiring the Space Shuttle in 2010, and it confirmed a human lunar return of 2020. As Mike mentioned, with the successful launch of STS-119, we now have the S6 thrust in place and the 4th solar array wing on the International Space Station, allowing us to have a crew of 6, but also to enable more science and engineering that will help us pave the way for improvements in our exploration portfolio beyond the Earth. And pragmatically and technically, we continue and will have great progress in this coming year. Most recently, we had the port test, which is essentially using the Orion capsule at Carter Rock Naval Facility in Maryland just this past week to do some water testing, and we'll be taking it to the Atlantic in the not so distant future. Likewise, this past Tuesday afternoon, we had the abort control motor high thrust test number 8 successful test, and that paves the way for our pad abort test later this summer. Likewise, we had the Lunar Reconnaissance Orbiter Albatross mission launching on an Atlas V later this spring, and that will take us back to the moon, and we will be developing some very great maps that will pave the way for our follow-on return to the moon with humans, as well as doing some excellent science. Upcoming also, with scheduled May 12th launch is STS-125, the Hubble Space Telescope Servicing mission, and the wonderful opportunities for science that represents are fantastic. And in turn, upon that successful return, we'll be looking to do Ares 1X, our flight test, as I mentioned earlier, later this summer. Likewise, Ares 5 and Altair request our Altair lunar lander RFPs for the design contracts are currently being reviewed as we speak. Our analog activities setting up this coming fall at Black Point Lava Flow in Arizona will refine our concept of operations for test activities and our key technology development partnerships that will enable a broader exploration environment. And that's unique in the fact that we use those very same training grounds to do our Apollo astronaut training activities in geology in the first time around. Constellation will also be looking at PDR in about a year. And from a science perspective, this is also in 2009 is going to be a very pivotal year. We're going to codify or solidify an initial set of level 1 exploration architectural requirements for science. And those will be a driver for our programmatic development. Likewise, we are solidifying our surface science scenarios, and we'll be rolling that into our broader international activities. And speaking of international activities, we recently concluded the International Space Exploration Coordination Group meeting in Yokohama, Japan. And there we brought 14, including NASA, of the world's space agencies together, and we're working towards defining the standards and the interoperability of the architectures and the mutual partnerships and plans necessary to safely and efficiently execute the global exploration strategy. And uniquely there, we are looking for next June as the reference point of departure architecture for our international community. And that in turn will inform our own NASA Lunar Surface Concept Review a little bit later in June of 2010. Commercially, as Mike mentioned, we're looking to strongly leverage our partnership. And in terms of cost for commercial transportation services, we've had just this past year the SpaceX successful 9-engine test. We've also got the orbital demo 1 coming up for SpaceX in the not so distant future. Orbital Sciences, our other funded space agreement partner, has had their PDR for both pressurized and unpressurized cargo modules, and they've recently announced that we're going to have a pressurized demo for their first demo flight. So lots of forward progress there. Within Constellation, we continue to maintain our March 2015 commitment for initial operational capability. We're working hard to optimize the budget that we have and minimize our risk while continuing to deliver on time to meet those stringent goals. Likewise, we have a plan, contracts are in place, the infrastructure is coming along nicely, and we think that it's strongly achievable. We're focused on workforce, our industrial base, supplier base, and also the educational outreach activities that will enable our next generation of global exploration, both human and robotic, because that synergy is vital to a successful set of future mission goals.